Alright, let's look at homework 5, problem number 2. Alright, so we have these linearly independent solutions of this differential equation to construct a particular solution satisfying these initial conditions. Alright, let's do that. Alright, so any solution y can be written as the linear combination of these solutions. So C1 e to the x plus C2 e to the 2x plus C3 x e to the 2x. Alright, so let's use the first initial condition here to get some clue. Alright, so plug in x equals 0. You will get e to the 0 is 1, so you're going to get C1. Again, another e to the 0, so plus C2. Right, 0, so that's gone. So this is supposed to be equal to 1. Alright, so let's take derivative here. First derivative. Derivative of that is the same thing. C1 e to the x. And derivative of this is because the chain rule, it's a 2C2 e to the 2x. Alright, here we have to use a product rule. Derivative of, let's say, C3x would be just a C3 times the second e to the 2x plus, alright, C3x times the derivative of that is 2 e to the 2x. Alright, so we have that. Then we can combine things a little bit together here. For example, we can, let's say, C1 e to the x is by itself. But these two guys, so I'm going to put these two guys together. So you have 2C2 plus C3 e to the 2x. And then you have a 2C3 x e to the 2x. Right? So then we use the second initial condition here. So we can just plug in 0. So y prime of 0 is equal to, right, that'll be 1. So it's going to be C1 plus, right, that'll be 1. So it's going to be 2C2 plus C3, and that's going to be equal to 4. Alright, so let's see, so we have a condition on C1 and C2, and we have another one involving C1, C2, and C3. Alright, so we're going to take another derivative. So y double prime is equal to, alright, derivative of that is C1 e to the x as always. So the derivative of that is going to be, actually, maybe go here. Derivative of that is going to be, right, multiply by 2. So it's going to be 4C2 plus 2C3 e to the 2x. Right? Derivative of that is going to be, let's see, derivative of that is a 2C3. Then multiply by second, plus you have a 4C3x e to the 2x. Right, just a product rule. Alright, then I'm gonna just combine these guys together. Actually, I'm gonna just go ahead and plug it in. So right, last initial condition is plug in 0. We're supposed to get 0. Right? So here we get C1 plus, right here we're going to get the 4C2 plus 2C3, and from here you have another 2C3, so plus 2C3, but this guy is 0. So actually, can I combine these guys and turn this into 4. Alright, and this is supposed to be equal to 0. Alright, so we have 3 of these equations. We should be able to find the C1, C2, and C3. Alright, so let's do that. Let's see. So we want to eliminate some variable. We can probably eliminate maybe C. Let's eliminate C3. Actually, I'm going to eliminate the C1 here. So by solving this, alright, I'm going to subtract C2. So we have a C1 is equal to 1 minus C2. Alright, so we're going to plug this in here. So you have this will give you 1 minus C2 plus 2C2 plus C3 is equal to 4, which will simplify 2. Alright, so I'm gonna subtract 1, so this is gonna be 3 on the other side. Right, negative C2 and 2C2 is 1C2 and plus C3. Right, so we got that. Here we plug in 1 minus C2, so we're gonna get I'm gonna go ahead and 1 minus C2, but you have a 4C2, so I'm gonna write a 3 C2, right, plus 4C3 is supposed to be 0. Alright, so we can just let's see, subtract 1, so you have a 3C2 plus a 4C3 is equal to negative 1. Right, then you can multiply these guys by, let's say, 3, so we can get let's see, yeah, 3C2 plus multiply by 3, 3C3 is equal to 9. So go through the subtraction. Right, you can see that it's going to be 0 here, and the C3 is equal to negative 10. Alright, we got the 1 value here, C3 value. Once you know C3 value, we can plug it in here. So you have from here, you have C2 minus 10 is equal to 3. So therefore, C2 is, so adding 10 to both sides, 13. Right? So we found the C2 value. Alright, once you have a C2 value, we can plug it in here. So this will give you C1 is equal to 1 minus 13. So it's going to be negative 12. Alright, so therefore, we have, so negative 12. Oops. I have to. So y is equal to negative 12 e to the x. Alright, C2 is 13 e to the 2x, and the last is negative 10 x e to the 2x. Alright, so that would be the particular solution satisfying those 3 initial conditions. Alright, looks like we got the right answer. Alright, that's it. I hope that this was clear.